Hello, welcome to AVOI AP Computer Science. My name is John Maxwell. Last night we opened the class looking at a problem that we'll have to do this week, which is number 17 in the Java Methods book. And so we'll take a look at what we discussed last night. First, we're going to read the problem. And I'm not going to read it here. I'll ask you to pause the video and to read the problem on page 173 of your book, and then check back with some comments. So now, after your pause, I will take a look at a class that I named Publishing. And what happens here is it's the first time you've encountered creating a method outside the main. And as the problem dictates, and I copied directly from the problem, it's get order total. If given the number of orders for be prepared and given the number of orders for next best here, it will calculate the cost of the order given the description in the problem, which basically is a long if, else structure. I have a placeholder here returning 0.0 because it specifies a double and I want this program to run. Well, how do we get down to here and have this code process? In line 17, we have an example of a call where we get order total and give it the values that it needs as actual parameters. And given that it returns a double, I set up a double order price to receive that value once the method get order total ends execution. So run it just so you see. Wow, what did I do? There hasn't been an error. What? Oh, I hit a little boopy there. Okay, and I need to put a closing brace in. So let me run it. And it runs with line 13, enter the be prepared quantity, and I'll hit 10 and then enter the next best quality 3, and it returns on line 17 0.0, which is outputted on line 18. So it seems pretty simple for you to just implement get order total using this template, and it will show you how a method can be called from another method. Also pertinent here are the setup of the variables gleaned from reading the problem. And I create them as final, meaning they're not going to change. And we put the values in that we get from the reading and create a scanner. These are called class variables because they're applicable anywhere within the opening and closing braces. Okay, so you can use these variables in the main as well as get order total. They're sort of universal, specific to this class. So it's a good setup to use final variables when you see the need for them. And so final, recall, means that that variable value cannot change. Last night we got a question about why is the main method always static, and we'll share here that when Java launches this program, it does not create an instance of a publishing object. Okay, so it doesn't have to have an object called the main method. It can be called simply by the notation publishing.main, and that serves a lot of memory utility in that it saves memory and decomplicates the software startup. But notice all the things in the context of this class are static, from the variables to the methods, and that is unique to a class with a static method. So that's a problem coming up. I'll give you a little lowdown on it, but we're going to shift off to another program to get more basic. All right, here we have a class called if-else-cow, and it has a main method, and it's used really for hardly anything at all but for instructions. So I have x equal 8, and of course I'm ignoring 9 for now, but if x is less than 9, print out less. If x is greater than 9, print out more, else print out equal. And so there's rife with logical mistakes here. And I'll run it, and it says less. Of course, x is less than 9. And then it says equal, because the else here is married or connected to line 15 if statement. And so you might call that a dangling else. It's not written properly. So last night, students quickly identified just putting an else here, an else if, corrects the problem. Okay, so watch what happens there, less. And so with an if, else, structure, the evaluation continues until a condition is true. And so if the first condition is true, it'll print out less and ignore anything past that. So it provides a mechanism for early exit, and I think that's the beauty of an if, else structure. And they're used all over programming to make decisions, big and small. Many of them are consequential. We can feel them. The Rocket Mortgage approval on your cell phone. Anything that involves a decision that is more quantitative, although they can be used in qualitative type analysis as well. So if, else, and you can put as many else ifs as you want there. Okay, so here's an example of that. I'll just add if x equal 9, and we'll just say we'll go without the else, and it still says less. So you can set it up the way you want, but it brings to a conversation. How are these comparison and relational operators working? Well, we have less than, greater than, less than or equal, greater than or equal. Here's something that's unique, not equal. Okay, an exclamation point and an equal sign. And of course, a double equal to compare equality. So these operators will work on primitive data types as well as strings, okay, but not on object types. So if you have an object perhaps called a task that encapsulates a task that you have, we'll learn about these later. Those are traditionally not using these comparison operators. Okay, so we're going to shift to string before I talk too much about and, or not, the logical operators. Okay, so I'm just going to uncomment this and discuss how strings are compared. So let me just comment this part out so we don't have to look at that briefly. And we've got that commented out. Now, let's start off with John and John. A comparison of equality. String name holds the same value as name 1. They are separate in memory locations, but they do hold the same value. And so here's a comparison with an equal equal. Here's a comparison with the dot equals method of the string class that we talked about last module. And here's compare to. So what happens is, it's true, John is the same in both variables, both on line 28 comparing with equal and on 29 using the dot equals, but 0 is outputted by compare to, which essentially says they're equal because 0 means both are the same. Okay, so let's look at less than 0 and greater than 0 examples. So I'll change this to Josiah, okay, and run it again. Now it's -11, and obviously John is not equal to Josiah, so they both report false on 28 and 29. But someone was pretty astute last night and mentioned that S is 11 places down from H, which means that John comes before Josiah. So when it's less than 0, the name comes before name 1. Well, name is what's calling compare to, and name 1 is the parameter. So when it's less, the evaluation hinges off of name. It will report -11. So let's put Edward in, like I left the program here, and say that's 5, because Edward is, following that example, 5 characters, the E of Edward before the J of John. So here's an example where John comes after name 1, or name comes after name 1. The comparison is all based on the thing which is called the implicit parameter. Okay, name 1 is called the implicit parameter, and this is the actual parameter. Name is the implicit parameter, name 1 is the actual parameter. So what happens is the comparison is based on the actual instance of the string class calling the compare to method. Okay, and in this case, the implicit parameter, the actual instance calling the compare to operator, is name. So that's the end of string comparison. I'm going to move back upstairs there to something else, okay, which I believe I can just take this and draw in false. Okay, so we have it pretty good. Let me just set it up as Boolean lost equal false. Okay, and so I will say lost and x plus 9. Well, what do you think is going to happen? They both have to be true when the AND condition is applied here, and lost is false. So what happens is the computer gets lazy and just evaluates the first part and never even looks at the second part. It's called short circuit evaluation. And the tricksters at the AP computer science folks, those tricksters are going to mix this in, and hopefully you'll remember short circuit evaluation when you see that on a problem. Okay. Well, the other part is that if it's less than 9, or, which I'm missing the key, it's shift. Okay, the two pipes signs on the PC keyboard above the enter. Probably never used the pipe very much before. Okay, and we'll just put lost. So the first part is evaluated, x is 8, and it never looks at the second part, even though lost is false, because if only one part of an OR condition is true, then the whole thing is true. So there's another example of short circuit evaluation. The part that I want to throw in here is the not sign, okay? If lost is false, what's not false? Correctly identified in the class as true, okay? And so the not sign is the negation operator, which reverses the value in the Boolean variable. Okay. So these are logical operators. But the important thing to know, and it'll come up in a coding bad problem, is the and comes before the or in every situation. So if you want an expression with or to happen first, make sure you use parentheses, because as it moves through an expression, it will encounter an and an or and do the and first. So let's revise priority. At the top of the heap is the not sign. It's occurring even before arithmetic, but that's not very practical. It's usually used with parentheses to guard against early application, but the not sign is the highest priority. Then we have arithmetic operators, multiplication, division, etc. Then we have the comparison or relational operators. So those evaluations occur first, and then the and then finally the or, and then the lowest of the heap is the equal sign, the assignment operator, which puts a value into a variable. So negation, arithmetic, comparison, logical, and before or, and that is the revised priority here. So what I want to do is shift over and do a couple of coding bat problems. Okay, this one you can read and pause if you want to pull up the problem, but it's a squirrel party, and you know, I don't endorse smoking cigars. However, it was put out by university guys, so perhaps they smoke them at the upper level, but it's successful when the number of cigars is between 40 and 60, unless it's the weekend. Whoopee! There's no upper limit. Return true if the given values lead to success, or false otherwise. And so we have Boolean return, which is a true and false value, and income cigars and on the weekend. So let me write one for you. If cigars is greater than or equal to 40, and here's an and, cigars, only type properly, is less than or equal to 60, and not is weekend. Okay, so it's not a weekend and it falls within that range. Return true. Okay, great. Super. We returned true for one of the conditions. Let me just go and say, if that was true, we want to stop execution. It would anyways, because it's returning true. So we'll go with a else if, and it just says if cigars is greater than or equal to 40 and is weekend, okay, as long as you have more than 40, then, and if it's a weekend, it's successful, we'll return true. And then finally, we can say that those are the conditions where it would return true, else return false. And it becomes successful. And so you can see an evaluation of that type here. I'm going to go to another problem that we did last night before we close. Okay, we're in logic 1. Caught speeding is always a little good one. Okay. You're driving a little too fast and you get pulled over. Write code to compute the result. 0, no ticket. 1, small ticket. 2, big ticket. If the speed is 60 or less, the result is 0. If the speed is 61 to 80 inclusive, the result is 1, small ticket for 80. Must live in another state. If the speed is 81 or more, the result is 2, unless it's your birthday, and on that day, your speed can be 5 higher. Okay, so we have Boolean as birthday, okay, right here. And we have speed, and it returns an int. So I'm going to start right off by negating is birthday. And you can say, how am I putting this value in a Boolean expression? Well, it is in itself a Boolean value. So I'm just going to minus equal 5 using the compound operator. Take 5 off the speed because you got a little break. That way I don't have to make as long and elaborate an if, else if structure. Okay, I can evaluate both the same by taking 5 off the top when it's a birthday. So now I have to read the problem. If speed is less than, what does it read? Is or less, okay. Ooh, but work the keyboard a little bit, okay. If that's true, we're going to return 0. Great. Okay, let's go to the else if. Else if speed is greater than 60 and speed is less than or equal to 80, okay, then we're going to return 1, okay. And what we want to do is realize that this is a common mistake that I've presented and corrected over the years. Speed is greater than 60 and less than or equal to 80. Okay, this is typing it wrong, okay? And it's a hard problem to get out of, but you know, there are 2 Boolean expressions here. Okay, this is an incomplete expression. Avoid this error. Well, I can assume that, like, if I got 0 and 1 right, I can just return true, or 2. So let's see. Perfect. Okay, last night I left this off, okay, and I got that, which says, hey, when I'm at 80, you know, there's a little bit of a problem. I'm returning, you know, 2 when I should get 1. So I'll put the equal sign in and show where logic can happen. And that's a common thing. It's a misread up there. When they use the word inclusive, they mean less than or equal to 80. Well, this is as far as I go today. I hope you have a wonderful day as well. And reach out, as always, if you have any questions. Thank you.